on this problem, the key is to understand how a spring works. Springs depend on two things, material and loops. The stiffer the material, the higher the K. The second thing is the number and size of loops. If you think about two springs, or if you think about a spring, when you stretch it, each loop has to stretch a certain amount. So it's like the load is distributed over the number of loops. So the more loops there are, the less each loop has to stretch to support the load. So that results in the fact that if you take a spring and cut it in half, you reduce the number of loops. And if you reduce the number of loops, then each loop has to stress more over the same weight. Like, so if you took this spring right here, if you took this spring with, let's say 1, 2, 3, 4, whatever, let's say 4 loops, and you put a mass on it of M, then each loop has to support 1/4 M. But if you take that loop, that spring, cut it in half, and now you only have 2 loops, then each loop must support half M. So that makes the spring work harder, and the spring has to pull harder. The harder the pull the spring, the higher the K. So if you cut the spring in half, you double the spring constant. Now, of course, whether you hang the mass on one single loop, 2 loops, or 4 loops, it's the same amount of weight. So all those springs pull the same. But but what happens is if you hang that mass on a higher spring constant spring, then that spring only stretches half as much. So if you cut the spring in half, you double the K. Okay, that's neat. See if I can switch back. You double the K, but you don't change the load. That's the same mass. But then each spring stretches only half as much.